Okay, so we're going to start chapter 6.
Yeah, that I got for the alpaca.
All right, so chapter 6 is going to start out with a review of some of the things that we've already done. So we've learned all the formulas. I introduced them in chapter 5.
So these are more complicated than those.
No, these are all, okay, so what I just put, review the properties of indefinite integrals. So remember, indefinite integrals, that's when you need to have the plus c at the end. So for example, if you have a constant, actually here, the constant can go out in front, right? If you have two functions added or subtracted, you can just distribute the integral. And then these are all the other formulas, the power formula. You take the exponent, you add 1, and then divide by that same.
Oh, you introduced it before, but now they only introduce
Right, so the book only introduces them in 6.2. We're going to do 6.1 later. There's just a reason I like to do it a little bit out of order. Okay, and remember, u to the negative 1 or x to the negative 1, that's the one that doesn't work, because if you add 1, you get 0, and then divide by 0, and that doesn't make sense, so that's actually the natural law. Yeah, a couple of you made that mistake on the test.
Say that again? Sorry.
Yes, when the only time the power rule does not work is when it's negative 1 in the exponent.
I got that.
And it's ln. It's natural.
Oh, I did that, right?
It's ln of the absolute value.
Oh, I didn't put the
Wait,
absolute
wait,
value.
there's one where you have to use ln, right?
Lauren?
Well, it's ln because then you put 1 over u to the 1, and that just is ln. That's just like the derivative of regular ln.
Right. So remember, if you take the derivative of this, you get 1 over u.
Yeah.
Remember, it's the antiderivative, so we're working backwards. The trig formulas you need to know, mainly the cosine, the sine, and the secant squared, but the other ones may show up. It's just those three are often the ones used most often. And then usually exponential will just be, I'll just usually give you the e to an exponent. There were other ones, but I'm not going to test you on those. Okay. So some of you were asking me if we use the chain rule with integrals.
Yeah.
Okay, and we do. We just have not encountered that yet. Okay.
Did I ask you
You
that
said you
yesterday?
said chapter 7.
She said
No,
6.
chapter 6. Chapter 7 is on area and volume. Okay, so the way that we use chain rule is that it involves using the derivative. So first thing, I actually kind of want to come back to this. So okay, so one of the things that we learned actually back in chapter 4 were differentials. I know it was a long time, but differentials just mainly mean we want to make sure that the dx is on the other side.
Oh.
Okay, so you know that du, like if we have du dx, this equals x prime of x. So could we just multiply both sides by dx? Yeah, so we just move it over there. Yeah, you can. So it's du equals u prime of x dx. And that's what we have right here. So we're going to be using differentials when we use this substitution process. So just a couple of quick examples. So if we start with u equals x squared, so think du dx would be 2x. So if we're moving the dx to the other side, it would just be 2x dx.
But isn't the dx like what they were doing? How do you just multiply it?
So du dx, so it's the change in u with respect to x.
Yeah.
So we're still saying it's the derivative, it's the change in u, but we're just moving the dx to the other side. You're going to see how it pieces together with the integral. Because remember, anytime you have an integral, that elongated s, you need to have dx also or dy or something on the right
If you're
side.
going to have the dx, then on the left side you have to have the du. Yeah.
Yeah. You'll see, it will make a lot more sense when we look at the
Okay.
examples. I'm just looking at just the differential. And again, we did those in chapter 4, so you can go back and look at that if you want to review. So if I want to do du here, it would be what? Sine of x to the third, and then because we have x to the third, you have to apply the chain rule. Or sorry, negative
Yeah,
sine
3x.
x to the third, and then you multiply by 3x squared.
Why is it negative? Oh.
Derivative of cosine is negative sine.
Oh, we're doing examples now.
Okay, so we're gonna, that's why I said it makes a little bit more
Yeah.
sense when we just go to the examples. It's kind
Yeah.
of hard to look at some of the theorems without really seeing it work. So x minus 7 to the third. You could multiply out x minus 7 times x minus 7 times x minus 7. Okay, but that would take a long time. What if it wasn't to the third? What if it was to the seventh? You're not gonna be able to multiply that out. Okay, or you could, but it would take a really long time. So we have this substitution process. So usually what we do is we let u equal the inside. So when you have a composition of functions and you're not sure, so in the first problems on the homework, it will say what u is equal to, but then there will be problems later on that you have to figure out what u is equal to. Okay, from here, du, well, what's the derivative of x? It's just going to be 1 dx, or just du is equal to dx.
Wait, you said
Thank
1
you.
for a second?
Thank you.
Where was the 1?
Well, okay, so if I were to write out du dx,
Okay, so
this would
that's-
just be
yeah.
equal to 1,
Okay,
right?
Okay, yeah.
So when I'm looking for just the differential, we just want to multiply, move the dx to the right side. So the 1 is kind of irrelevant here. Okay, so now what we want to do is we want to take this whole thing and rewrite
Is there any time that it would be equal to 1?
yes, lots of times.
Dude, Lauren, stop.
Can we keep going on?
This case.
Oh, if there's a constant in front of the u?
Do something.
Control yourself. How's that? Or leave the room.
Oh.
Okay, rewrite in terms of u. So that means I'm going to get rid of anything that has x in it, and I want to replace with u. Okay, so here. So basically this, let me just rewrite it. So dx, that's equal to du. So I'm going to replace that with du. And x minus 7, that's what I made u equal to in the very beginning. So this whole thing is going to be integral of u to the third du. Now that, we need to have whatever variable you change this to. So if we change this to u, you have to have du. You can't keep that as dx. It doesn't make any sense to integrate with respect to a different variable. Now do you see why we needed the differentials? We just wanted to have the du, not du dx.
So you can just replace anything within the parentheses with u and then put it to that power?
Yeah.
I
Now,
still don't understand what we're trying to find or what
we're trying to find this integral here, but the problem is that it's a composition of functions. So we can't just,
you're changing it.
right.
It's
This one,
backwards changing.
I mean, you
That sounds
can.
impossible.
Is it to the 4?
This is going to be to the fourth over 4, but the only reason we can apply that here is because the derivative of the inside is 1. But let's say this was 2x minus 7, then it doesn't work. You can't just say 2x minus 7 to the fourth over 4.
So then also the case is
If the derivative of the inside is 1, then we can just do the integral like we normally.
but you could
I'll
also
have
do
that.
this.
Yeah,
Right.
I'm
So just do this
showing
one.
you. I'm just showing you lots of steps here. I'll try to make it simple in the next one. So now this is x to the fourth over 4 plus c. So right here. So we're going to integrate.
So you substitute u
Oh,
for
okay,
x
okay.
minus 7.
So once we have everything with u, now that it's u to the third, I can use my power rule. I can't use my power rule if I have a function inside, but if it's just a variable to a power, then I can use my power rule. Remember, right up here? U to the n du equals u to the n plus 1 over n plus 1. But I had something other than just u. I had an x plus 7. So that changes
Why
everything.
is it so
Okay, so okay, so once we're all done, remember we started with x. What's that?
Isn't it minus 1 plus x plus 7? It's x minus 1.
Oh, I made a mistake. Yeah, it was supposed to be minus. Okay, so we just want to make sure that if we started with something with x in the beginning, that our final answer has to be in terms of x at the end.
This is like, why can't you just do that from the main one?
Yeah.
Just take the x minus 7.
Okay,
before.
so if you were,
Does it get more complicated?
if you had listened, I said the only reason this
Oh,
you could
because
apply
of the
that is
one.
because the derivative is 1. But if the derivative's other than 1,
Yeah.
then it doesn't work. So this is an example that doesn't work.
Okay, let's do it.
Because the antiderivative of e to the x is e to the x. But I don't have just e to the x. I have a 2x in front.
Wait,
I have a 2x here.
why does you equal 2x in
Okay, so when you have exponents, so it's not as clear on these types of problems because the inside on the, that was pretty easy to determine. But when we have exponential functions, the inside is our exponent.
It was like derivative. You can tell we had like last week. It's like, remember when we did derivatives, usually it's for e's, you find the derivative of the exponent, but when you're simply trying to just like dash minus 7, you find the like right there.
Okay, so whenever, if you have an exponential function, and that's where you want to just make sure the exponent is your inside. Okay, so here's u. So du is equal to 2 dx. Remember, du dx would be equal to 2.
So dx is equal to du over 2.
Is the 2 referring to the coefficient of x or the 2 of the coefficient of e?
The coefficient of x. U is 2x, so du is 2 dx. You just take the derivative and then just put dx at the end.
So when you substitute dx in terms of u, then it's going to be du over 2. So then you do that.
Right? What do you mean du over 2?
Like how next you're going to put in u. And when you write
You're gonna
dx
put it
in
in
terms
terms
of
of-
u, it's going to be du over 2.
Right. Okay, so there's a couple ways we could approach the next part. First of all, I see a 2. I see here a 2 and a dx. Here's a 2 and a dx.
Oh,
So actually this whole thing here, so these two parts put together are du.
so it's e to the 2x.
Just think about this. This is all multiplied together, right? So does it really matter if the 2's out in front or if the 2 is right next to the dx? If you want, do you want to rearrange it? Would it help to rearrange it?
No, but that
Oh,
would be
no, I got
the.
it.
And this is u. Now my integral, so remember this is where we want to change everything from x, we want to change it to u. So I have e to the u du. Okay, so I can't do anything with e. E has to be in the problem. The 2x, I'm going to replace that with a u. And remember the 2 dx combined to be just du. And don't put the du, the d part goes at the end.
Well, when you
always.
put the 2 in front of because the 2 was part of the
Yeah, Olivia?
On the test, are you going to say what u is?
Not always, no. I'll give you a couple questions where I'll tell you what u is equal to, and then a couple where you have to figure it out. Most of them it's pretty obvious. I'll explain how you know.
Is u the derivative of the inside?
No. Du is, yes, du is the derivative of the inside, but it's a differential, so it's the derivative of the inside dx.
Oh.
Remember, guys, it's really just, we're just substituting. It looks complicated because we're taking the derivative of a part of it, and then we're just replacing the parts. So wherever you see an x, try to replace it with something in terms of u. So I see a 2x here. Well, that was equal to u, so I'm going to replace that with u. I see a 2 and a dx. That's equal to du. So is there anything that was unaccounted for? No. So now,
Where'd you get to you from?
okay, so now that it's just e to the u, that's easy to integrate. Oops. Oh, no, I didn't. The derivative, the antiderivative of e to the u is just e to the u plus c. And then remember, our final answer is just taking what we originally had as u and substituted that back in.
So whenever there is a number in front of the it's part of the du. Right, but then it's part of the du, but it goes well, but wait, what if, for example,
Here, you know what? Let me, can I show you just, maybe this will make more sense if I do it this way, because this is how I'm going to do it on the next page. So I had u is equal to 2x. So if that didn't make sense, just pay attention and pick that up. Okay, so du is 2 dx. Everybody's okay with that, right? Just, I'm just starting
Yeah,
from over
yeah.
again. U is equal to 2x, so du is 2 dx.
Because
Now
you
let's,
take the derivative of u, right?
right, so now let's say I want to get rid of the 2. So 1/2 du is equal to dx.
Yeah.
Why didn't you have that before? Before it was 2.
Sometimes, if you don't, I'm showing you a different way. Sometimes if you solve for dx, so remember what I had here. I had 2e to the 2x dx, right? So now if I take 1/2 du and substitute that in, I end up with 2. Are you okay if I just write e to the u here?
Yeah.
Times 1/2 du. What do you notice about the 2 and the 1/2 over here? They cancel. Okay. And now we actually took care of that all in one step here.
Yeah.
But you can also divide.
Like,
No, it won't always happen.
then how would you wait, let's the other way.
Okay, that's where I have other examples.
Okay.
Boring.
I don't know my math.
Would you just like to teach yourself?
No, I like to leave.
All right, let's look at this example. So not always is everything going to be so obvious. I'm just trying to show you, I know these don't seem very basic, but these are kind of the basic ones, and they can get more difficult. But like I said, in the beginning, I'm always going to show you what u is equal to. So u, okay, what's inside? It's x squared plus 1. So what? So let's do du. It would be 2x
Yeah.
dx. Now look here. I have a 2x and I have a dx. So that's du. So these two combined.
Do we keep the
Okay.
what's it called?
Yes, you keep the square root. Olivia?
Why is
dx. I understood the other ones where the 2 is the coefficient of the x, but how is 2x?
What's the derivative of x squared?
2. Oh, so you get the derivative?
You take the derivative.
Wow.
Okay. And x squared plus u, or sorry, x squared plus 1 is u. So this gets to be rewritten as the square root of u du. So it's almost like whatever I've used, I kind of replace it there. I just think of it as almost like canceling it out. Now, this is u to the 1/2 du. So it's u to the 3/2 over 3/2 plus c.
Oh, plus C.
So it's 2/3. And then now I can just replace the u with x squared plus 1
Oh, you leave
to the
it
3/2 plus c. Okay, so usually the most difficult part is in the beginning where you're trying to piece it together so you can write it in terms of u. Once you have everything as u, it's much easier to integrate. And then you just plug back in. But this part where you get this line, that's usually the most difficult, just making sure that you've substituted everything in correctly. Are we okay on that one?
Yeah. I got this one much better.
Okay. Let's look at this one.
There's a lot of things to remember.
There is a lot to remember. So this one, what's du?
Can you assume that u is just everything that's not equal? Wait, u is sine. There's
Yeah.
2x sine x dx.
Okay, don't worry about that. I have an exponential function. It has a cosine x, but I told you u is cosine just to help you out with that.
So can't you just
What's du?
decide that u is
Sine
everything
x
that's
dx.
not u? Yeah. Right?
Isn't it negative?
Negative, but isn't, since the
Okay.
derivative of sin x cosine x?
Yeah, the derivative. We haven't. This is derivative.
I know, the derivative of sin x is cosine x.
So the derivative of cosine x is negative sine x.
Yeah.
Wait,
Really?
Yeah.
you're not
Yeah.
doing antiderivative, you're doing derivative. Yeah.
Okay, so we work forward. We use the derivative. Yes, the derivative of sine is cosine. The derivative of cosine
Is
is
negative.
negative sine. And then dx.
Why is it negative? What's the derivative of cosine?
But I thought that du was.
I thought du was everything besides for
U.
It just happened to be it ends up being that.
I didn't think about that. Okay, now, if I look back at my original, I have a sine x and a dx, but I don't have a negative. So that means negative du will be equal to sine x dx. This is just a coefficient. And I usually just say put in front. It just makes it easy if you have a coefficient, just put it out in front of the whole thing so you don't get confused.
So
Alexis.
if du is the derivative of u, then why in the problem before this did you say that like did you circle those two and make that du? Why did you know like wouldn't it be the derivative of x squared plus 1, which happens to be the same thing as that?
Yeah, that's how it works, like the derivative of that.
But not in D.
Not in D. D, we're missing a negative sign. So sometimes when you do the derivative, it will show up exactly as you see it in the original problem.
You
But you
always
can't
do the
assume
derivative.
it's that.
So now I'm
Right.
starting to show you that it doesn't always look exactly the same. Sometimes there's a coefficient that's missing. In fact, often that's what's happening, is that you're missing the coefficient part of it. You need to have the sign. We wouldn't have been able to solve this without the sign there. Because these two combined right here, this is negative du. You see that? So I need to just make sure whenever you end up with something that's other than just du, like a 2 du or a 1/3 du, you have to compensate for that in the integral when you write it in terms of u. Olivia?
On tests, if you're gonna have two x's, would you like tell us which one you're talking about and you use? Because I would be confused. I would say sine x or cosine.
Okay, but remember, what did I say when you have an exponential function? What do we always make u equal to? You make it equal to the exponent. That's what I had noted previously. So when you have a variable in your exponent, that's what you're gonna make, or in an unknown.
Would the next step be negative e to the u du,
Right.
right?
Yeah, Lauren.
Then like what if it was like cos x e to the cos x? Then the derivative
I
would
wouldn't
be
give you that.
negative
I
sin
wouldn't
x.
give you can't do that with substitution.
Okay.
So e to the u du. Sine x dx was replaced with a negative. You see that? Here's my negative. And then du I put at the end. And then it's e to the u, because cosine x was my u. Negative e to the u plus c. Right? The negative just comes along. It's just a coefficient. You don't need to multiply it to the c. C can always just be plus c. You don't have to distribute anything. You'll see what c means later.
Got it.
We'll actually be solving for c in 6 point whatever.
Oh, I love that one.
6.1.
We can leave a cos x up
I can't remember. 6.4, I think.
We leave the cos x up there. There's no, like, anti-derivative.
See if you could do e on your own. Just try it.
I did it.
I
see
tried,
it.
but I can't.
Well, I just need over the
Case, how hard did you try?
This hard. I didn't know what to do next.
Think about
Because
it.
you put it in, and then u equals 3dx. There is no
So what equals
Okay.
dx? What equals dx?
over 3. But
Yes,
where do you
yes.
put that over 3
It's a
then?
coefficient.
Oh, it's 1/3.
It's like the negative.
Okay, so remember how we had to throw this negative out in front? So remember, we didn't have a negative in our derivative. And here, I don't have a 3. There's no 3. I mean, there's a 3 inside, but there's not like a separate 3. So I need to compensate for that missing 3. And I have to multiply du times a third. So whenever you end up with a coefficient that does not exist here, you multiply by the reciprocal.
You want to make
We didn't really have to worry about reciprocal here because it was the reciprocal of -1 is -1. But here, dx,
It's the same as that thing.
this is 1/3 du. So I really have u, here, I'll just show you. This is u to the 4th times 1/3 du, basically. But remember, I don't like to deal with coefficients until the end, so I'm just going to take that move it to the front. If you did, you'll notice I'm usually going to do this in one step later on. So when I end up with a 1/3 du, any coefficient of du, just multiply that to the front of the integral. Because now, just look at u to the 4th du. Happy comes. U to the 5th over. So it's going to be 1/3 times u to the 5th over 5 plus c. Again, don't worry about, you don't have to distribute, which is, well, what's u to the, so 3x plus 1 to the 5th over 15 plus c. Or if you want to make it 1/15, that's fine. So remember, what does the integral represent? It represents area under the curve. So when we had numbers, when we had a bound below, like when we had numbers here and here, we had we had a finite area under the curve. Well, what if it goes on forever? Are we ever going to be able to come up with the area under the curve? No, but we can find a formula for it, and then the plus c is going to be determined on what you make those bounds later. Lauren?
Why on this one? Can you go up? Sorry. Yeah, I have a question with both problems. E,
Okay.
A, and U. Why would this one, after we had E and the U, on D, we just plugged in U, and on this one, we have to do antiderivative.
Well, what's the antiderivative of e to the u? E to the u. E is the only one that the integral and the derivative are the same.
All right. Yeah.
Okay. How about this? Anybody want to attempt it?
Yeah.
Annie?
So du equals 6x.
So I see that we have an x squared and a dx, but I don't have a 6. So I have to compensate by multiplying everything by 1/6 out in front. Do we understand that? Questions about that?
So what do you do with the x squared dx?
Well, this is equal to du, basically. So these two are 1/6 du. So I'll put my du here and my 1/6 out in front. How's that? Then I have the integral of what? To the 1/2, u to the 1/2. See how nice that is? So it looks really complicated to begin with, but when you get to change it all in terms of u, it just makes it a much easier integral to work with. Isn't that
But
so
that's
pretty now?
yeah, it's just
That's what I'm saying. Look at here. That looks so pretty. Now 1/6. Don't worry about multiplying to 1/6. Just do the u to the 3 halves over 3 halves. So that'll be 2/3 u to the 3 halves, and then the plus c. So we get 1/9, and then 5 plus 2x to the 3rd, all to the 3 halves, plus c. Question?
Can we just put that whole thing on a 9?
Sure, that's fine. That's the same thing as I said in the previous problem. Like you could either put it all over 15 or do 1/15. Same thing here. Are we done with this? I want to. Not everybody's taking it.
Don't worry, Justin won't finish it, by the way. Justin's
He's fine.
butt. Justin's a baby. Justin's a baby.
It's gonna be on YouTube.
Justin, you're a baby!
All right.
He's not even gonna look at this.
I promise you I'm
This
gonna
was actually so helpful.
Okay.
I used them.
But there are other people that. Okay.
I love you, Justin. There you go.
Let's see. I don't want to have. We don't have to go through all of this. I just want to get through.
Does it get harder?
I want to get through this, and I know some of you want to. We'll talk. Let me just go through let me go through 2 more examples, and then we'll take a break, and you guys can. You won't be able to finish the entire homework assignment. That's the only problem. Okay, so u substitution. Notice here I didn't say what u is equal to.
It's the same thing.
What do you think you're going to make? So.
U equals 2x minus 3. Oh, just minus.
Right. So this implies.
But because there's an exponent there, it doesn't matter.
But it's not a variable in the exponent. So du,
Do this a little quietly?
you want to try this on your own? Go for it.
Do you want it?
No?
Can I do it on the board?
I really like this. This is kind of like a little challenging, but not really. It's
It
pretty
doesn't matter which other one you want.
Both up here.
This on the tablet or the
Do tablet,
SMR?
tablet,
Do like
tablet.
the tablet.
This is easier to write because you can rest your hand and just write smoother.
Right. So. Wait, 1/2.
See a 2 anywhere, so they have to compensate for that by multiplying by half out in front. Actually,
Where's
I
you?
do want to one thing.
Yeah.
So you should have it over 10, 1.
Yeah.
I don't know what to put as the value for the next one.
What's the U for B?
I'm going to another part of the lesson. So, but I'll post it on high. Okay.
Thank you. Sorry about that. Thomas is always not having some nice stuff.
No, I just need to fix the 1/2 and the 5, right?
Yeah, just make it all content. Give us the option of writing an essay, but,
Yeah, no, we're writing 21 over essays.
The whole thing, or
yep, that's good. And then plus C.
plus C, right? Yeah.
Thank you so much. I'll watch the screencast.
I can do it.
All right. Are you guys good with this?
Yeah.
Okay. Oh, question. Okay, so let me do this next example, and then I want to move down to one more thing.
Yeah, maybe
Justin's been gone for weeks, though.
Okay, so this one, it was pretty obvious what we want to make equal to u. But the next problem, we have some other stuff going on. So we have an ln, this is actually ln to the third, and then over x. So think of this. This is like ln of x to the third. All right. It's kind of like sine, cosine, tangent when we put the variable between. It just
Times
means
another x.
over x.
Oh.
So what do you think we're going to make u equal to? What's inside? ln of x. Not the x. The x is not inside. It's separate.
Why'd you change?
Just so you're used to seeing ln.
because she wanted to.
No.
I changed it so that you could see with parentheses what's inside. So what's du?
1 over x dx.
1 over
And it's
x.
there, so we don't need to mess with it.
Ah, 1 over x dx. That's du. You see that? So I can rewrite this as u to the third du. So what looked, again, complicated in the beginning, once we use the u substitution, now it's just u to the third du.
I really like this chapter.
Isn't this nice? Okay, so what do we get? U to the?
Do we need to, okay, you should write it like that on ln x to the 4th.
Oh, so if you want to use parentheses and write natural log of x and then outside parentheses put 4's power, that's fine. They mean the same thing. Yeah. So if you want to write it like this. They're the same. Okay, I want to do one more thing. I'm going to scroll down to the next page. We'll finish these on Tuesday. I have 2 days for 6.2, but I want to get to one more thing because I know some of you like to be able to do the homework. And I'm collecting homework more often next chapter, so make sure you pay attention to the dates there.
Hey, don't say all of it.
So, the next one, we have bounds. So we don't need to worry about the plus c, but what we end up doing is once we change everything to u, we're also going to change the bounds. Again, this looks much more complicated.
Let's
It
try
makes
it.
it much easier. Let's just look at this original problem. Pretend the bounds aren't there. Think, what are you going to make u equal to?
X squared minus 4.
All right.
Am I right?
Yes. Because think of x squared minus 4. Think x squared minus 4 in parentheses is really to the -1. You know, if you... So it's like this. Do you see how I rewrote it? So now it's a little bit more clear what's inside. Are you okay with that? So du would be...
But we have to go 1/2.
Right, I don't see, so I have a 1/2 du will be equal to x dx. Okay, so this is going to be equal to, don't put the bounds yet. We have a 1/2 bound in front.
This on the top count as the x for the dx.
The x and the dx are du, so
Or is there any rewrite it?
it's really u to the -1 du.
Is the proper way
Okay,
to do
now.
it to have du on the outside? I mean, glass.
Yes, du, you always need to have less. Now I don't, sorry. 0 and 1 are, that would be fine if we had everything in terms of x. But now that I changed everything in terms of u, I want to change the bounds. So remember u is equal to x squared minus 4. So if I figure out what u of 0 equals 1. So plug in 0. 0 squared minus 4 is -4. So that becomes my new lower bound.
-3.
And then it becomes negative. So that becomes my upper bound. I plugged into you.
Two numbers that are already on.
Plug the x values in.
Into
Yeah.
that, and that's your new bound, because you have to make.
So what's nice about doing this substitution method with you, we don't have to go back and rewrite it in terms of x. Now that I changed my bounds, I can just
Oh, really?
integrate, and it's just a definite integral.
Oh,
So I have 1/2. Oops, not 1/3. What do we get inside here? ln of absolute value of u, evaluated from -4 to -3.
Wait. Absolute value. Okay, yeah.
One over.
Remember, ln is always absolute value because you can't have an ln of a negative.
So if it's like
Where did I
x to
lose you?
-1 or 1 to
This is the one rule where if we try to add 1 to the exponent and divide by it, we get undefined. So that's ln.
Okay, so that is just 1 over u, which is ln.
Right. If you want to write that as 1 over u, that's fine.
It's gonna be a long thing in parentheses like that.
It's going to be ln of 3 minus ln of 4. Or you could rewrite it if you remember your log. Do you remember subtraction turns in? That's what I said. I'll be okay with that answer for you.
You don't plug u back in?
What's that?
You don't plug u back in?
No, so that's the nice thing when you change your bounds. You don't have to go back and plug back in. You don't have to go back to x. Remember when we did the indefinite integral, we had to always go back and rewrite it in terms of x? You don't need to do that here.
Now we changed it to the integrals of u.
Right. Otherwise, you're plugging back into, like you'd have to rewrite it with x and then plug back in the original.
David,
Okay.
do basketball?
No.